Hey guys, it's Vince. Today in this video, I'm going to be covering how to troubleshoot your CNC robot like an engineer. This is a process I put together early on in my career and with well over 400 videos on my channel and dealing with consultations roughly at about 30 a month. It really makes sense to cover this in great detail because I feel that this genre is growing so fast. This is the one area most vendors will never ever explain to their end users, and on top of that, do they understand it themselves? I find that most people just go about identifying problems as they happen, and they don't really think about the level of detail required to really pass on the knowledge of what's going on with their robot, whether it be their controller or the hardware itself, to other end users who are there to support them. So let's jump right in. I hope that this information will help you, and I hope you watch the video all the way through because I give you a lot of tools that I use, and hopefully you'll find great value in it. Anybody who's clicked on this video plans on watching it to the end. It's not going to be short, but it is going to be thorough, and I promise you it will save you money in the long run. There is no doubt in my mind. A tech coming out to your shop to work with you can be anywhere between $300 to $1,000. I know that's what I charge up to, and I can tell you right now, I hear it all the time, all across the country. So sit down and let's cover this outline that I've covered. First topic I want to discuss is first motion controller run test is performed off the chassis. When I say chassis, guys, I'm talking about your router, I'm talking about your plasma, I'm talking about your water jet. Keep the controller, motors, and everything aside from the chassis. This isolates any possible motion issues to other subsystems, which eliminates the motion controller as a variable. If the system test is successful, document the date and time for referencing. This is used to provide a stability timeline on your components. Now think about what I just said there. Okay, I can't tell you how many clients of mine, and even potential clients of mine, never ever think that far ahead. They immediately get the controller, or it comes bolted on their system because they bought it from China warehouse, or another area online, whether it be overseas or another vendor, and they immediately power the unit up. The first thing you should do with a new system is test it by itself. We want to eliminate all subsystems. For those of you who are unaware of what a subsystem is, a subsystem that I'm defining is any major component system. Your controller and all accessories that go with it, meaning your motors, your cables, your connectors, one subsystem. Spindle, or your cutting torch, or whatever it may be that you're performing your cutting with, that would be another subsystem. Okay? If you have a spindle, it would be a spindle cable, spindle connector, VFD. All of that, of course, with the spindle itself, would make up the spindle subsystem. And we go on from there, whether it be enclosure, switches, all of that would be, you can encompass that in the controller itself. However, you can separate other components any way you like in that subsystem grouping, but the idea is to keep the subsystems as huge as possible, so to speak, so that it encompasses all of the components in one direct category. That's what we're trying to do. So if you document that system is stable off your chassis, and you've tested air cutting, you've run some G-code, everything is running good, perfect, document it, give yourself a stability timeline, start that document, be as complete and as detail-oriented as possible. Discuss it. X-axis works great, Y-axis, Z, so on and so forth. This way, you know exactly how this system was behaving at a set time, and you have that to reference to if there ever is a need to. Think about that. Okay? It makes you think more. It makes you retain more knowledge. Okay? The first test run of your controller should include motors, cables, and all connectors attached. And all connectors attached, guys, is simply the controller. That's motors, cables, and again, all connectors, motor. You want to just provide air motion. That is it. Okay? Once that system has been tested, okay, if you wanted to, you could either then choose to mount to your chassis. I choose not to. Okay? I would recommend you test your chassis. If you can, test your chassis with a cordless drill. 9 out of 10 of you can test the chassis with a cordless drill. My pro grade guys may not be able to do that. Okay, if you can't do that, you really move into the next step where you'd mount your motors so you can do a full system chassis test. If you have the ability to use a cordless drill, it has enough torque, test your chassis axis before mounting everything. Check for loose bolts, check for linearity, common sense type stuff. Okay? If you encounter an issue with the above test, get a legal pad or open a spreadsheet to begin documenting your troubleshooting steps, detailing the result of each possible solution attempt. Think about what I just said there. If you're documenting everything, and what usually happens is, whether it be, potential clients, past clients, whatever it may be, I get messages that say things like, this is doing this, I don't know why I'm getting this. This is happening this way, but it only does it randomly. This is doing, I am not there with you guys. I have no visuality of your system. I have no audible, there's no way I can audibly hear your system. So anything that's happening is what you provide me in detail. If you're lazy and won't provide me the proper detail, there is no way I can provide support. I am not doing what Gecko does and sending out a form that you fill out and telling you guys, hey, look at my controller and look at this power supply and look at the... 9 out of 10 of you know how to check a power supply, or should, with a multimeter. So I'm assuming you've already done that. If you didn't, then naturally, the more detail you provide, the better off we are. I would like to see every bit of detail provided when you request support. Also, for your own reference, too many people are relying on memory. I don't understand that concept. It does not make any sense to me. And it really, when you're frustrated, your memory goes in the toilet. I mean, the more aggravated you get with something, you're not going to memorize what you tried and what you attempted. The best thing to do is, like I said, take the legal pad or get a spreadsheet, start it from the beginning. And you do this from the beginning, and I guarantee you, if you do this process as you get your system and start assembling it, you will have more knowledge of your system than you ever thought you would. I mean, you're going to find out a lot of different things. So now that we've gone there and you encounter an issue, you begin this tedious process by removing one variable component at a time. So again, if you guys are going through and you find that with the controller subsystem, we'll just start with that. If you find that you're testing the system and you find that there is a component that is not working as it should, whether it be an axis or whatever, I'm assuming it be an axis, you would want to start naturally with that axis, which most of you do, but most of you get lazy at one point or another and say, well, I've tested this. Okay, if you're not documenting, that is a sign of laziness, because I guarantee you're forgetting something. When I say test every component, guys, I mean remove every cable, remove every motor, every connector, one at a time. If you still don't find it, you connect one component at a time to see what end result happens. If you do one motor and one motor connector, you're going to find really quick, install one of them on a drive axis at a time. If you have a G540, you have 4 ports for motors, you would do one at a time to see what that process actually entails, and you would see exactly what you would see from your system. If the system is not giving you any feedback and you're not seeing any problem rectified, then okay, we move to the next component, next motor, next cable, so on and so forth. It is tedious. It is time consuming, and that's why engineers and techs get paid what they do. Now you understand it. When you go through it yourself, you're going to find out that this process is not for the meek. It's not for people that, want quick fixes. A lot of times that's what everybody hopes for. Once again, the guys that are involved in CNC understand the time it takes to become really adept at what they're doing. And troubleshooting, I'm telling you, this video is going to save you a ton of money if you follow it. So once again, tedious process. You can go through validating each single component. If you have a 3 or 4 axis system hooked up, you would start by selecting the axis, and through process of elimination, removing one component at a time till you have just a controller hooked up to the wall outlet, meaning you just have the box, nothing else hooked up. If you notice that the box is still giving you trouble, because sometimes you'll have either a red light on the Gecko or whatnot, then it's time to isolate the controller itself. If you've already tried all the axis individually as well as together with motor cables and all accessories attached, and you disconnect them and tried them individually one at a time, still did not rectify the issue, it's time to tear open the controller and start analyzing each component of the controller. The motors and cables of each axis reflect no issue, then move to the control itself, and once again documenting everything you attempt to correct the issue. Details are key. Don't rely on memory. Okay, guys? I'm telling you again, don't rely on your memory. Write every attempt of a solution down, every outcome. I tried testing the power supply with voltmeter. Voltage was dated, done. Did nothing. Still doing the same thing. Tried testing the e-stop. Did this, did nothing. If you're doing a Chinese system, this method is applicable to any CNC. I don't care what size it is. You can use this on anything. Okay? It will work, I promise you. You just have to put the time in. Review all controller variables based on components, motors, all cables, connectors, relays, electronic accessories, drives, power supply switches, system wiring. Once again, now you know why we make that kind of money. And again, that's why I'm saying to you guys, when you hear this and when you see this, this is the kind of tediousness you have to have with detail. When you see motors, all cables, connectors, relays, electronic, I mean, that's a ton of stuff potentially based on your system. Going through the motors, you guys have already done. Cables, I'm assuming you've already covered all that. Your relays, if you guys have plasma systems or you have integrated systems where you're dealing with spindle manipulation, you're going to have to go through all this. It's going to take time, and you have to go through each component based on what you find. This way, you can isolate what's there. Most guys, once again, don't want to do this. Electronic accessories. What other additional accessories do you have in the box? Your drives, whether it be G540 or individual drives, your power supply, switches, system wiring. I have seen so many different variables when it comes to system wiring, which I know it sounds crazy. Backwards wiring, loose wires, poor connections, poor grounding, you name it. So that's why I'm saying all of this has to be documented. Every single one, you guys now have a checklist right here, and then we move on. Once all the controller's variables have been tested and validated, it's time to move to the next subsystem following the exact method outlined. Now, guys, that just means practicing exactly what we did here. Review spindle variables. That would be your next subsystem. If you guys have my plasma guys out there, you would start with your torch, go on, so on and so forth. Most of you are going to have a relay to cycle the torch on and off. You may have a torch height controller. That adds another variable. You could see just how easy and extensive this can be. And again, if you have a process and you're documenting, it makes everything so much smoother. So let's see here. You got your spindle connector, spindle cable, VFD spindle wiring, documenting all details of process of elimination. Once again, what did you try as a solution and what was the effect, if any? If it didn't have an effect, so be it, and date everything. You want to know a date so you have a point of reference. Hey, I tried this on this date, didn't work. And then tomorrow, you can say, well, I tried that yesterday, and you always have it recorded. A week goes by, you could say, hey, I tried it. Once again, it's all about details. Review all chassis variables. Once again, we've isolated another subsystem. You got your spindle as a subsystem, chassis as a subsystem. Axis provides smooth operation. Review your transmission, i.e. ball screws, lead screws, rack and pinion, or belt drive. Those are the majority of the chassis, guys, as far as transmissions. If you validate your ball screws, your lead screws, your rack and pinion, and belt drive for smoothness, everything on them. Go through everything. Go through the straightness of the screws. Go through the bearings. I cannot emphasize that enough. If you guys are using a retrofitted system or a used system, tear the system apart. Don't be lazy. So many guys take these people that are selling these systems words, oh, the unit was cleaned, it was not abused. Guys, I've yet to see a system out of the box be used unless it was from a corporation that has servicing details on the system. Don't take anyone's word for it. Go over the system so you know that your time and money is going to be well spent. I cannot emphasize that enough. Never believe anything. Anybody can say anything, and most likely will when it comes to the investment you guys are spending. So be careful. Okay, Loctite applied to all bolts. Using a torque screwdriver on all fasteners. Guys, buy a torque screwdriver. Torque screwdrivers are not that expensive, and they'll let you assemble your chassis with even torque on all fasteners, and it will give you just an overall wellness to know that everything is balanced on the chassis. It should. You're building a robot. Take the time. Everything that can be measured should be measured. Torque is something that should be measured. You'll never strip a screw. You'll never have problems with that. And I promise you, it will pay off in the long run. Once again, documenting all details of process of elimination. So as you've gone through your chassis, you just got in your 6040 from China, you're assembling it, that's the first thing you would do is break this into subsystems as far as assembly. Just reverse the process. I'm going to go over the chassis variables, go over my ball screws, my lead screws, everything. The more you assemble, the more you get your hands on things, you're learning, and again, you can do it right the first time. Review all computer variables. Guys, I cannot tell you how many issues are driven around computer variables. I have clients who have told me stories of, I'm using, such and such computer from 1985, or a computer that, doesn't have enough memory in it, or whatever. I am going to just tell you point blank, if you're running Windows 10 and you have, 4 gigs of memory in it, in your system, and it's, from 1996, that's not going to work with what you're doing with these applications. So do yourself a favor. If you have to invest to do it right, okay? Or go back to Windows XP and deal with the fact that Microsoft no longer supports it. I mean, that's something you're going to have to look at. But I have a lot of clients, and what scares me is I've had even past clients where they look at spending the money on a computer and really make a big deal about it. Computers are not that expensive today. And to do it right and have a system that's isolated just for this type of programming is not really that big a deal. I mean, it scares me when I hear of a corporation or a business telling me that, they're using computers that are 9 or 10 years old. That's frightening, guys. I mean, and then they complain when they have problems, and it's scary. I mean, that really is scary. So think about what you're investing in. Think about your computer. Think about what's installed into it. I personally like computers that just have the operating system installed and are just dedicated for that process, whether it be CAD/CAM, whether it be Mach 3, which are typically all integrated on one system. I like laptops. That's the way I like them set up. That's me. Your preference may be different. A desktop is fine. Just be realistic. If you got a computer from your neighbor's yard sale and it's 1985 to 1995, you're going to have problems. Odds are it's going to rear its ugly head in all kinds of different instances. Certain people out there are saying, no, there's nothing wrong with that. You do what you want. I would rather stay with technology that's supported, because then at least I know I'm not going backwards. The more you have to hunt online for support, especially like I said, through third-party vendors who don't even, you're not even confident in accepting their support or even wanting to, call them because they don't have a contact number, it really makes sense to just look at the investment, weigh where you're going with this, and look at how much you're paying yourself, because if you don't put any monetary points on your time, you're really going backwards. Because I can't tell you how many clients of mine tell me, oh yeah, I've spent, such and such time, working through this problem, and it's like you're going backwards. You get to a point where you got 10, 11 hours into something when you're trying to review what's wrong with it, and the only thing you're really doing is beating your head against the wall because you're not willing to make a change because it costs money. There comes a point in time where you got to say enough is enough. And that's why I say the computer as a variable is huge, huge. After everything else has been done above, the chassis, the spindle or cutting tool, whatever it may be, the controller, everything has been done above as far as where you are in troubleshooting and actually performing a system stability check. You would then review all EMI contamination possibilities. Once again, only after confirming all the above troubleshooting on an otherwise stable system has been completed and documented. If every cable isn't properly shielded with ground drain attached to a grounded source, then begin with going over the system, completely replacing all inferior cables to ones designed around robotics use. Guys, I'm telling you now, this week alone, probably three to four questions alone on EMI contamination. Is my system EMI contaminated? Is this? Is it so I'm getting ghosting in the machine? I'm getting random e-stops. If you have not performed all of the troubleshooting methods I've outlined above, there is no way I'm going to be able to definitively tell you if it's EMI. Only you can tell you that. You have to document everything, perform a time study on the system because you're willing to put the time in once again, and then you can confirm, okay, I've tested everything else. This is what I've done. I'm moving on to EMI now to make sure everything is dialed in. If you buy a used system, EMI is going to be there. If you buy a new system, it's going to be there. EMI is present all the time. We're trying to reduce it. And the only way to reduce it, again, is with properly shielded cables. Okay? When I say shielded, I don't just mean buying the cable and connecting it. That's not what I mean. You have to attach the drain, the actual shield drain, to a ground to dissipate all of the EMI. This way the cable is clean. If you don't do that, you've got a standard cable. And a lot of guys don't. I see it online all the time. I see it online. It's frightening. The guys that buy these Chinese systems and get the VFDs installed in the chassis. I've done videos on this in the past. And, you know, they message me and they don't understand why they're having problems with the drive. You got a 3-phase inverter surrounded by DC drives in a vicinity that's maybe 10 to 12 inches in width and length. Come on, guys. We have to think here with competency and common sense. You got an AC inverter that's literally going in and dealing, you know, in voltage ranges of 220 and above, converting everything, and then you've got a DC driver sitting there, and that EMI is just pounding that drive. Regardless of the quality of the drive, the EMI that's present is ridiculous. So the first thing you should do is go over your system, if you haven't already, and really look at what's going on in the system. Even if it's stable right now, go out there, check it out. Become one with it in the sense that you know every piece of hardware and you understand what you're doing. Once you do that, like I said, it's gonna open up huge doors for you because you'll never be stumped when something does arise. And with something like EMI, I can tell you right now, it can hit you anytime, any place. You might have a system that you think is stable for 3 months, and all of a sudden you get this weird, all of a sudden it starts ghosting out of nothing. I don't know what happened. My limit switches are going off by themselves. Okay. And everything was stable before. Yeah. Is anything documented? No. So, again, you're not going to have a timeline if you don't document. You're not going to have stability checks if you don't document. Everything with these systems should be documented. If you go to Nestle, if you go to UPS, if you go to FedEx, DHL, if you go to Walmart, and when I'm talking Walmart, I'm actually talking about their production facilities as far as for shipping, the warehouses. All of their automation equipment have documentation, and that's why they do. You guys are doing the same as these companies, but smaller. So why would you not practice what the big boys do? It doesn't make sense. Think about it. Document everything. Don't be lazy. Don't be lazy. There's no machinist that's lazy that's successful. If they're going to be good, they're going to document everything. And for you to understand this is really to go through it. And I can't tell you, the guys that contact me, I really feel for when they tell me how many times, whether it be, like I said, it's really sad when it's third-party U.S. supporting vendors who just, you know, either they don't feel confident with or they won't help them, or, you know, they're just struggling so much. Oh, I just hate this. I don't know what to do. I'm wasting my time. I'm wasting substrates. This is crazy. I'm spending money. I don't know what to do. And it's sad, but it's the truth. If you guys practice this outline, there's virtually no system you will not be able to troubleshoot. It depends on how detailed you are. Once again, all components sending or receiving signals require shielded cables. Let's say it again. All components sending or receiving signals require shielded cables. Okay? It does not matter what that is. If it's a relay, shield it. Okay? You're going to have bleed through. You're requesting a signal to be sent to turn on the digital switch. You want it to be shielded. Do not second guess the equipment. Don't sit there and think, oh, well, my system's stable, I don't have to do it. A lot of guys are lazy, and they just don't want to put the time in to do it right, and it's sad. It really is. And then you contact me and insult my time and education because I'm going to tell you the same thing, and then when I request a picture or video, I don't get it, and that just draws another big question mark, like, what do you have to hide? I mean, if you did it right, you would be proud of showing it. You know, that's the way I look at it. If I did something right, I'm going to show you. If I don't do something right, I'm going to hesitate, or I'm going to keep asking redundant questions that, once again, you're practicing the definition of insanity. So really think about what you guys are doing. Think about what you're projecting, okay? Once the system is stable, document any changes you make to the system to once again provide yourself a stability timeline. Think about that, guys. You got a system, it's been running great. You bought yourself a relay kit. You install it, now you have all kinds of problems. If you have a timeline of what the system was, you can eliminate a lot of components that you already know were checked and validated. Getting on checked and validated on a stable system. Let's talk about that for a minute. Pro-grade facilities have what's known as PIs, or PMs, preventative maintenance. Okay? We used to do them all the time. If you're not doing a PM on your machine at a set hourly rate, let's say, let's just set an arbitrary rate of every 15 hours of runtime, you do an hour PM on your machine. You will learn a ton on doing those PMs. If you just get your machine performing these PMs at a closer timeline is even better, maybe on a 5-hour runtime, because she's new. You're still getting new. The more time you invest, once again, going over the redundancy of evaluating everything, seeing how she performs, and I know you guys get so excited about making cuts and everything. She's not going anywhere. You're better off learning the machine, learning the hardware at that point, and saying, okay, I've got it down. After a week or two, expand the timeline. That's the best way to do it. A week or two, expand that timeline. Say I'm going to go 5 hours now the first week, and then I'm going to go out to 10 hours. And in this way, you document a PM. I went over the control. I went over all my bolts. I went over the axis. Everything looks good. Motor cables look good. You'll get to a point, I promise you, that those PMs will go by so fast. Even if you cut the time down, let's say 45 minutes to a half hour, if that machine is making you money, isn't it worth it? You're saving your hardware. You're saving your own frustration. It makes sense. Think about it. Take the time and practice every method that the Fortune 500s do. Just practice them without actually needing them. Do you see what I'm saying? You've got all this knowledge. We're doing the same thing that these guys are doing that are producing most of the products in America, whether it be overseas or here, and you own the equipment. You have to implement their same strategies, and that will keep your equipment running, and it will keep you guys informed of what's actually going on. And then if you do, God forbid, have to contact a vendor, whether it be me or anybody else, you guys can provide them the required information that will show, hey, he's put the time in. He's really trying to dictate this, and boom, he's there. I have to say the truth, though. If you follow this outline, go through this entire outline and think about it logically and put together an actual outline for yourself that applies to your particular hardware and environment, you will find you're going to basically be able to determine a lot just from doing it yourself. Like I said, a 95 to 98% success rate after just going over everything. You know, like I said, 9 out of 10 systems that are coming overseas, you already know most of your cables are not even shielded. I would say about 99% of the systems I've seen coming from overseas aren't shielded. I have seen systems, I'll be honest with you, I've seen systems come in that use shielded cable that have no drains attached to grounds. So it's useless. And that's the thing. There is no cheap way out, guys. There's no cheap way out. I say that all the time because I get clients that come to me. I give them a price, or I should say potential clients. I give them a price. Then they go hunting around, and they're like, oh, hey, I can get it here, this too. I'm not going to lower my price. I know what I'm selling. I know the knowledge I'm giving you guys. I'm not hiding behind the internet. I make the phone calls. I do what I should do. I'm not going to drop my price because I feel that I'm worth that, and I know my knowledge is worth that. A lot of my clients consider me an expert. I don't. I think I consider myself more of an advanced user because I'm doing over 500 systems total average a year. And I can tell you right now, with that kind of electrical knowledge, doing this every day, dealing with the questions every day that get thrown at me, you do tend to get better. And that means I can take that knowledge and pass it on to you to make you guys save money. I feel it's kind of like just a kick in the crotch when somebody sits there and you want to negotiate with me on what I know and what I say, when if you practice what I'm writing right here, you're fine. I already know you're going to be fine because you'll go through it and all of a sudden, oh, hey, it's this. Oh, hey, it's that. I get so many messages daily. Oh, you were right. It was this. Or, oh, you were right. It was that. When they could have just followed this outline that I provided, and I guarantee you they would have found it themselves. And like I said, hopefully they get in touch with me first. If they call their vendors, I can't tell you how many vendors are charging for, the second they pick up the phone, it's an immediate sales call. So I'm telling you now, go through the process. Think about it. and you'll see exactly what I'm saying. I mean, if you go through the process and you try it, it's going to be tedious the first run. After you do the first process of actually getting your system, once again, setting up the controller off the chassis, testing it, validating the actual chassis works, and you create that timeline, then you guys are going to be tenfold ahead of the game. You already know that chassis is stable. You bolted it to your electrical enclosure. Your controller is stable. I don't want to confuse the terms, confuse anybody. Once you then bolt the controller to your chassis, after the controller has been validated as working fine and she's smooth and you've got it documented, once you bolt to the chassis, you move to the next step. Okay, the chassis has been validated. Now you're joining those two component subsystems together and you know they're stable. Then you go on, document it. Okay, chassis stable, controller is stable. We'll start our PM 5 hours from now, 5 hours of use from now. Start the timer when you're in the shop, average it out, whichever way you want to do it. Be as precise as possible. The more detail you put into it, I promise you it will pay off, guys. There's nothing easy about CNC. There's not. You're building an automation robot. And I mean, when you think about it in them terms, everybody says CNC. You're building a manufacturing robot is essentially what you're building. Okay? It's incredible that we have the technology to do it. It's incredible now the price point that we have the technology to do it. And to me, it just makes sense. It makes sense that if I'm going to build an automation robot, I'm going to put the time it takes in to build a robot that's going to produce products that I'm proud to produce, that I'll put my name on. And that means doing it right. So invest this time in yourselves. Go through, read this, copy this, whatever you've got to do. And like I said, I know this video will save you a ton of money in the long run. There is no doubt in my mind. For those of you out there who are new, for those of you out there who are advanced users, most of the guys that are advanced users are probably already shaking their head, oh, what he's saying makes sense. I already know it. I mean, the guys that have been around this, they know. The guys that are in, corporations, they talk to me and they know. They know exactly what I'm saying. That's why I'm telling you guys, the novice guys out there, the guys that are just getting their feet wet or just looking at spending that big investment on their first chassis, it's a large elephant you're trying to eat, and that's why I say do it one step at a time. Reverse troubleshooting is the best, and like I said, that's just a simple process of eliminating the subsystems on a new system, and in this way, when it comes time that troubleshooting is required, you guys are 10 steps ahead, being you've documented everything, you've got that timeline to refer to. So again, I hope this video has been helpful. I know the questions are going to definitely come in, and let them, but I'm going to tell you now, if you haven't watched the video all the way through, I'm going to send you back to the video because this video now covers everything. So I'm hoping that when now questions come in that they will follow this format so that we're all on the same page. Once you guys are on the same page and again treating me as if I'm literally blind and deaf, then I can then do my best to help you, and I think other vendors will too. I hope, especially in the US, I hope that's the case. But like I said, for those end users who feel alone, who feel that the forums and I hate forums, you guys all know how I feel about that, but for the forums out there, this is the pinnacle of really defining your system and defining your knowledge. I've got Microsoft Excel. Nothing special here, guys. Very, very basic. Again, I use Excel because I like a digital format for my data. If you want to use handwritten notes, that's fine. Whatever way you want to do it. I do have 2 clients that like to take audio recordings. If you want to do it that way, that's fine. The big thing here, and the one thing I want you to really pay attention to, it's all about detail. And when I say detail, pretend that someone just, God forbid, murdered someone that you love, and you're the homicide detective trying to identify who the murderer is. You want that kind of detail. That kind of ridiculous kind of detail is what you want to do, because, again, the more variables that you can give us as far as what you've checked, what you've done, when you did it, what time did it happen, again, the more detail you record, the more power and the more information you can provide to hopefully get the issue solved if you can't figure it out yourself. So what we have here, jumping right in, again, we have troubleshooting template, we have system issue, subsystems included in the loop, variables, possible causes, solutions executed, and I have technician. I'm going to cover most of these because, again,
Some of them are self-explanatory. System issue, again, that's naturally going to be what you're actually writing the report on. As we go through this, though, there will be some, like subsystems included in the loop, you may not know. Okay, so I'm going to discuss that real quick. Subsystems, really, if we look over here at possible causes, we realize that possible causes go with the system issue. System won't power up, so your possible causes, and you always want to start at the absolute base level, which of course would be the wall input. Okay, where you plug the system in from the wall, and then the actual wire then runs into the enclosure or wherever you have your driver and power supply located, you're going to have your wall input. You're going to want to check that. Okay, so once again, you're going to start at the absolute base level. You're going to look at the wall input, and you see I wrote here solutions executed. Under this heading, I wrote verified 8/29/2016 at 10:30 a.m. Okay, because again, we verified that the wall input was okay. You also see here where it says wiring from wall input, system power supply, and G540. Okay, so this is basically your entire power subsystem. Okay, meaning you're going from your wall, the wiring from the wall input, then you go in system power supply and right to the G540. That's the subsystem. If, however, you had a relay or two relays or extra switches or whatever else that would go in between all of this, that's what you would want to check. Now, there are some type of instances where you may buy, and I have guys that'll buy breakout boards, not for a G540, but for another driver set. If you're watching this video and you want to implement this for your own set, keep in mind that some things you may not be able to troubleshoot because they're built into your board. That's why in my previous videos I always talk about actually keeping your subsystems separate. In this instance, you have a wall input subsystem, wiring from wall input subsystem, power supply subsystem, G540 subsystem. Why are they subsystems? Because they can be broken down. If it's a solid item where you make this all a loop, and when they're all connected they become a loop, they are now not a subsystem until you break them down. So remember, individual components are subsystems. When it's actually connected to formulate a system, it's now a fully built subsystem. So in this instance, when this is all connected, that would make one subsystem. Keep in mind that, again, the more items you add, if you have a plasma system, okay, or a different system where you have more motors, you're going to go through here. Let's say you have a motor issue, or in this case we said system won't power up. So if you had a torch height controller and it was connected in this loop, you'd have to troubleshoot your torch height controller as well, or at least find it in this list wherever it would fall. Again, I always start at the base level: wall input, wiring, power supply, then you would have torch height, and then you would have G540. So your torch height controller would have to be checked. That means there's more time to assess what the actual issue is. Now, if you write here like I did, where I said verified 8/29/2016 10:30 a.m., is it really necessary to write the date and the time? Yes, it is. And here's why. If you ever encounter this problem again, you will know that it happened to you before and what you did to try to solve the problem, which in turn means that you're seeing the issue again. So if you ever have to contact a technician, you could say, hey, this happened to me multiple times now. You can give them dates, you can give them times, you can give them the scenarios in which it occurred. And again, you're providing him more information on saying, well, maybe we should just get you a new component, or, maybe it's this. That's what we're trying to do here. We want to make you be able to provide as much accurate information as possible, not just to me or some other technician, but also to yourself, because the more you get to see what's actually going on with the machine and the better you become at dissecting your own machine, you're going to really learn it at a totally different mechanical level. And that's, again, where you want to be. I don't care if you're a hobbyist, I don't care if you're novice or advanced, this process is the correct way to go about troubleshooting your system and doing it with precision to where you're able to identify problems quickly and hopefully through the process of trial and error find a solution, because typically it will happen, and I would say about 85% of the time it really is where the end user solves his own problem. The other 15% you would actually be closer to calling a technician, and when you do provide the information you actually did, 9 out of 10 times you'll blow his wig off, because he'll be amazed that you actually went through all that and have that kind of detail recorded. And trust me, it's a nice feeling, because then he knows exactly where to go with helping you. So overall, hopefully this has been somewhat helpful. Again, subsystems included in the loop, no other items in loop, because again, we only have wall input, wiring from the wall input, system power supply, and G540. We don't have anything oddball here. We don't have a relay. We don't have any of that. So basically, you went through, you're going to verify each component until you find the culprit. And again, if system won't power up and this is all you have, you're really only going to come down to the G540 and find out exactly where this all goes. Okay, now in an instance, let's hypothetically say, for example, that you find everything here is good, but the G540 is the one that's actually giving you the issues. Okay, you're going to come over here, and when I have technician listed, you're going to call Gecko's tech support, and you would naturally talk to him. And I would request that you actually take down the technician's name, take down the technician, what time you spoke to the technician. You want to record as much information on who you're dealing with, so that if you ever have to cover this issue again, you can talk to the same technician. See, with me, you're always going to talk to me. When you call other companies, 9 out of 10 times they have other people working. If you encounter someone on a different shift, or if you encounter maybe not even a different shift, maybe he's off in general, your odds are you're going to have to recover this information again, or just go by the notes that the original technician took, and that can be just a real PIA. So overall, you want to really take the ball out of their court and do the homework, and it will help streamline this process tremendously. So now, as you guys see, what we're looking at here, I went from subsystems included in loop, no other items in loop. Now you understand what a subsystem is. We have variables. Now I wrote here first time issue. What does that mean? Well, if the system won't power up and it's the first time you've ever encountered it, logic states that we write down first time issue. I also wrote a note here, and you see me once again, I wrote down 8/29/2016 at 9 a.m. This is when this first occurred. Okay, once again, extreme amount of detail. You know the time it occurred, you know it's a first time issue, and then you're going to go from there. And then again, we come over to here, possible causes. You could see now I'm dissecting this. I'm performing more or less an autopsy on my machine to find out exactly where the cause is. What is causing this? How can I do this? How can I identify the cause enough to where at least I know I've covered everything to the best of my ability, and the only thing left to do is either contact a technician or really identify each manufacturer's technician and go from there. That's what we're looking at doing. So once again, you would write down the verified. I already wrote this down as just an example, and then let's say you verified the other piece. You could come over here, and this again is why I like Excel. You could see you can come down here and go paste, and then you can go down here and go paste. And again, you should always record the time in which you're doing this. In this case, if you did it all at 10:30, which for example I did, then you'd be fine doing that. And once again, you see everything is done for you. And once again, you can also see why I like digital formatting, because you can manipulate information almost instantly. So again, that's what we're looking at. Okay. On top of the fact, when you do stuff like this, and I can't emphasize this enough, you are going to become so smart with your machine, because you're going to know, you're going to pick up different things from the way she sounds, the way she produces components, wear points, anything in the machine that normally you would only really pay attention to when parts wear out. Too many things on YouTube I found are all about movement and all about, oh, hey, look at me make a part. None of it is about the real intricacies of taking care of the machine. And the thing is, none of this equipment is 100% perfect all the time. I mean, 9 out of 10 of the things you find on YouTube is problems. So really, it kind of surprises me no one's ever done a video like this, but I think it really shows that where the market now is so new, and guys are still looking at, getting involved in this. I hope this truly helps everyone in the sense that they'll have the information they need and the knowledge to actually develop something like this for themselves and make them stronger. I can't emphasize that enough. It is tedious to do. I mean, this is very time consuming to do, but I promise you, the education you'll get, not just to provide the technician with the amount of information required to really isolate your issue, but the education you get by learning the machine, it's priceless, guys. There's no school you're going to get this kind of information, because no one knows your machine like you do, especially if you built it. I have guys building their machines all the time and encounter problems, and a system like this will identify a problem almost immediately, at least to the point to where you're like, okay, I'm stumped. I've done everything, and I can prove I've done everything, right down to date and time, and now it's time for me to call and get some answers on certain components. So that's really where we want to go with this. That's why I said Detail is everything. As a machinist, if you're learning to be a machinist, and essentially we all are, if that's what you're doing when you purchase a machine, you're looking at controlling a robot, and you're using that robot to manufacture. No one buys CNC equipment for inaccuracies. If that was the case, you'd buy a handsaw. You're buying a CNC for precision. Use that same amount of precision you expect from a machine to actually go through and maintain it, and I guarantee you the payoff is just extraordinary, and I really mean that. It's going to really streamline the process of you learning everything. Okay, so once again, going through this, you want to record all the times and dates, so of course if it ever happens again you can go through that. One of the big things here, and I've had this happen a couple times after covering this with a couple clients, and once again using their own methods, where I've written down here, like I said, first time issue. First time issue on a problem like this is pretty basic. System won't power up, very, very basic problem, not something here where there's a variable. Okay, let's discuss variables. A variable is where you're looking at more of an inconsistent problem. Okay, those are the ones that really are tricky. When you run into inconsistent problems, I'm going to give you a hint. 85% of the time, I'd say 90% of the time, it typically is software related. Okay, typically when a file is corrupt, I would say overall you're probably going to see 90% of the time something there is amiss with software, whether it be what you created, something in the software is not playing well with something else, but 90% of the time it's software related. 10% of the time, I would definitely say the remaining 10% would definitely be EMI, which is electromagnetic interference or noise. Because if you're dealing with a metal chassis, we're dealing with electronics, you're always going to have EMI present. You always want to make sure you're shielding and grounding your equipment properly, especially if you're using a high power commercial grade spindle. Even if you're not using a commercial grade spindle, you'd still want to ground everything properly. So once again, take into consideration all of this, because this is stuff that's going to help you immensely, especially when, again, you're trying to do everything right, and you're excited, you've bolted everything together, you've put the time in, you've done your research, you've got everything done, you so to speak, and then you encounter this. Number one, you're dealing with frustration, you're trying to keep your head on and be focused. This right here will do it. If you ever encounter the situation, I totally recommend taking a step back if you are frustrated and coming back to it when your mind is fresh, because we all get frustrated, and the worst thing you can do is just be in a rush. Don't be in a rush. Take your time, be a scientist, and learn as you go. And believe me, it will pay off. So once again, I hope that this video has helped. I think you guys can see exactly where I'm going with this. But overall, I can't emphasize enough just how awesome this is to go back and actually use. I mean, I don't care if you have, once again, a computer, a car. I use this on my vehicles. It works amazing, especially if you go to a mechanic and it's a sporadic problem. If it's a variable, once again, it goes over here. Sporadic problem. What did you do prior to encountering a problem? Did you change from Mach 3 to Linux? I have some guys that like to try just different operating systems, different motion control software. If you did that, write it down. Okay, you're going to write everything down. Any change you make to the machine, I would write down. Anything you've done to the machine prior to testing, write it down. That's your variable. Okay, then if you ever go back and you look, you're like, oh, look, I did that. I can go back and I can revert that back, and we'll see what happens. And then if you do that right there through the process of trial and error, you don't have to be Orville and Wilbur Wright. I mean, that's what, a lot of the best inventors of their time, that's what they use is trial and error, and that's how they learn. We are doing essentially the same, because a lot of times if you've created your own machine, even if you bought a machine, you're hoping everything is done right. Again, you don't know that till you get it in-house and you actually set it up, and then you're waiting to produce a product or go over exactly the settings to make her function, and you're hoping everything is correct. So once again, write it down. If your feed rate today, if you go in and you say, you know what, I was able to cut my IPM with 70, and again, I recommend using comments if you are going to use Excel just for spacing. That's my own preference. I'm going to say changed end mill. Okay. And right now, what we know, and again, keep everything neat. The neater it is, the more organized you are, the more you think better. You'll think clearer. Okay, changed ML. I was actually running at 70 IPM. Yesterday when I was using the old ML, I was at 50 IPM. Okay, so IPM 50, and then you go there, and that gives you just, again, visual notes going through every change you make, always recorded. I guarantee you that if you do that and you find you encounter an issue, it becomes almost stupid easy to revert back. And then what I would do, again, if you're going through this, again, come under your solutions executed, and you can come over here at any time and revert back to the date, the time, and you'll have all that information right there ready to dissect and ready for you to try in the event that you encounter that problem again. I mean, it's pretty amazing. Not to mention, I'm telling you this now because, again, I deal with a lot of technicians. I'm human like you are. There's times I have questions and I need answers too. I record a technician's name down. I record the time. And when you approach somebody, just as a normal, socialistic approach, if you call somebody, a company, and you say, hey, can I speak to Christian, if that's who you spoke to, let's just say, for example, and he says, yeah, that's me. That already tells him that you're paying attention. That tells him that you care enough to, oh, man, you remember my name. That's cool. It gives you just that personal effect to where now when they're actually speaking to you, now they're looking at, okay, this guy's really paying attention. He's really there to learn. I'm going to go that route. I'm going to go the extra mile. Think like that. Don't forget respect. Don't forget to think in terms of you're trying to get as much help as possible. And one of the toughest things in this industry overall, which you're probably going to find almost immediately, is the lack of knowledge in the sense that it may be there, but it's only there at certain times. It's there when you buy the machine. It's there when you're looking at the machine. As soon as it's bought, odds are that's when it's either getting costly to have support, or it gets to the point where support is kind of at their beck and call when you decide, hey, it's Sunday night, midnight, I got an order to fill by Tuesday, my machine goes down, I contact him at midnight, okay, I don't get an answer because, again, it's late at night, but I'm hoping Monday morning early, 5 a.m., I'm going to get an answer. And guess what? It's usually not the case. So take into consideration all that when you're doing this. And once again, like I said, that extra bit of respect where you do write down someone's name. You do say, hey, I remember I spoke to you. I did everything you said, so-and-so, whatever you guided me on, and this is where I'm at. Where can we go from here? I guarantee you'll get the results you're looking for, whether it be a direct part replacement, if components need to be replaced, so be it. But overall, what you're overall looking at doing is making it to where you've got the education yourself that your machine better than the tech. And that's really what you want to prove. You want to make it to where every base has been covered that you can possibly do other than rebuilding that drive. You've done it. Hey, I've done this already. Sorry, I did this. And 9 out of 10 times you'll call, and I can only relate this to Bright House. I just had this happen recently. That's who I have as my internet provider. And you call, and they instantly go off into their jargon, the technician does, about what they can do to help you. Okay, did you try this? Did you try that? I always politely like to say, hey, you know what? Let me tell you what I've done, and then we can go into your list, and then you can go from there. This way you're better educated on what I've done to help provide me a solution to what I'm encountering. And usually that works out well. It really does. So now you guys have a really good assessment of what system I use, and what, again, this is not just a system I use. I didn't make this up, guys. This is factually used by some of the largest corporations in the world in manufacturing. Okay, so think about that. If you just use 10% of what I've just told you to make your machine a better machine and make you a more educated end user, this is going to pay for itself in a very short amount of time. So really, I hope you gained something from this. If you guys have any questions, let me know. Once again, my name is Vince, eDealers Direct, lead engineer. I can tell you right now that if you do have any questions, don't be afraid of leaving me your number. I can give you a call. A lot of times I like doing phone calls because, number one, I like talking to my people, mainly because I can cover a lot more information in a short amount of time. I don't have a lot of time during the day to do a lot of tech support, and when I do, I want to be precise. I also, if you have questions on actual builds, I'm there to help as much as possible. Anyone who's worked with me will tell you that. The big thing is that a lot of times to do a custom build or do those type of, to give that extra support where it's needed, to do that in email would take weeks of going back and forth. I prefer phone calls because, again, it is personal. It does cover your needs directly, and to me, that's old school business, and that's the way it should be done. Okay, guys, that wraps up another video, and again, I hope many of you have watched it to the end. Using the method that I've outlined is very, very tedious, but I promise you, you will become that much stronger in identifying any issues with your robot. And the better you get, I have a lot of clients now that document prior history of where they started with their robot from the get-go, whether they're just setting it up or making a slight adjustment, and they are so good at identifying any variable now that has been changed that they can go back, refer to the notes, and boom, they find out exactly what's going on. And I hope many of you are able to do the same. And once again, all my information is in this video if you do require any additional support, but I definitely think following the steps outlined here will definitely put you all on the right track. Take care.